You are welcome back to Labi Premium Consult. On this channel, we share educational content ranging from accounting to mathematics. So, if you are new on this channel, please kindly consider to subscribe to this channel. Make sure to like this video. Like this video 1,000 times, okay? Please like this video so you can get more engagement on this video. So, on this video, we're going to look at KSB level 100 mixed semester pass question. So, let's go through it in that case. So this is our first question. So as I said, if you are new on this channel, I've covered 3 series parts of this MCQ tutorials. They are on the description section of this video. You can check after watching this. You can also check and go back and then watch those videos as well, so that it can help you to understand the concept when it comes to statistics and how the various questions are solved. So without wasting my time, let's move on straight away to our first question 1. You are to use the information to answer question 1 to 3. Given that variable x, this variable s, is represented by the series, so we have what, 3, we have 3, 1, 4, 2, and what, 3. We are asked to find what, respectively, we are asked to find the value of what, summation. This is how I think it should be. Summation x squared. That's what we are asked to find. So how do you go by finding summation x squared? It's very simple. All you need to do here is to square the various elements that we have, which is 3, 1, 4, 2, and 3. You square each value, so you're going to sum them. So you're going to be something like this: 3, you squared it, plus 1, you squared it, plus 4, you squared it, plus, then you come to 2, you squared it, plus 3, then you squared it. So that is the whole approach when it comes to summation under this case. So let's take note of that. So I've given a nice presentation about how it is goes. So let's see how I also made that one in that case. So as you can see here, as I covered in just previous, you can see that it was the same thing I did here, right? Sure. So 3 squared, 1 squared, 4 squared, 2 squared, and what, 3 squared again. So when you square 3, you're going to get 9. When you square 1, you're getting what, the same as 1. When you square 4, you're going to get 16. When you square 2, you're going to get 4. When you square 3, you're going to get what, 9. So at the end of the day, if I should add all of these, you should be able to get what, 39. And that was option what, B in that case. So option B is the right answer in that case. So that is the summation. Is very simple and get it right. So let's continue. So please, if you haven't liked, make sure to like this video so we can get more engagement. Thank you. So let's move on. Question 2. You are also asked to find the value of what, summation x or squared. Summation x or squared. So how you also go by it? Remember the values were what, 3. Let's go back and see the values that we were having. So these were the values. It was what, 3, 1, 4, 2, and what, 3. Good. So that was the value that we are having. So we're going to just sum all of them up. So 3 plus what? Let's check once again. 3 plus 1 plus 4 plus 2 plus 3. So plus 1 plus 4 plus 2 plus what, 3. At the end of the day, you squared it. Okay, you squared it. So whatever you're going to get should be your answer in that case. So here 3 plus 1 will give me what, 4, plus 4 will give me what, 8. Is that okay? 8 plus 2 will give me 10. 10 plus 3 will give me what, 13. So 13 squared. what is 13 squared? And resulting to be, with your help of a calculator, you can say that 13 squared is going to give you what? 169 in that case. So that is resulting to be what? Option what? B in that case. So let's see. I also made a nice presentation about also this one too. So that's the same approach that you're going to be using in that case. So let's take note of that. So as you can see here, the same thing that I could just cover by now. So just sum them up: 3 plus 1 plus 4 plus 2 plus what? 3. Whatever you get, we had what? 13. So I'll square the 13, then I'll get my 169, because that is what the question actually told us, was summation x or what square. So I just summing up all the values of x, then you square it. Once you get the value for the summation, then you square it, and that will be all in that case. So let's take note of that. I hope you are getting some values out of this. If you are getting some values out of this, please try to like this video, okay? Like and comment, and let's see whether you are getting the concept I'm building much more better. All right, so let's continue. We have to find what? The mean of the series. To find the mean of the series, that mean x bar is equal to, so here it's on group, so it becomes a summation x over what? N. Is that okay? So this will be the formula that will guide you in that case. So you just summing up all the terms, and I remember when we sum up all, we had 13. If you remember from the previous question, you see it was what? 13. Right. So all I will do here is divide 13 by what? And the total number of series was what? 1, 2, 3, 4, 5 was 5. So divide by 5, and then our answer should be what? 2.6 in that case. So with a calculator, you're able to get 2.6 in that case. So let's take it. So that's how you find mean from on group data. Just sum all the values up and then divide by their number in that case, or their frequency in that case. So that is the whole deal in that. So let's continue. So this was the final part, or the summary part of question 3. So as you can see here, I sum up all the values for the series and I divided by what? 5. The 5. And the result then resulted in what? C. That was 2.5. So that was option C, 2.5 in that case. So let's take note of that. So let's move on to question 4. Which of the following variable is a discrete? And I believe that you have been following through our discussion on MCQ solving right from the beginning that we started. You can clearly see that this question is even a bonus question to you, okay? Because this question has been repeating itself on occasion, because if you check the previous video you have covered, this question has always been repeating up. So if you have been following through, then here you won't get any problem. You get to know that the answer is straight away. Is that okay? So let's see. Which of the following variable is a discrete? Length of rod, time of journey, number of oranges in basket, then masses of women. So which of them is going to be is what? The number of what? Oranges in the basket. For discrete data, you're talking about what? The value, right? Talking about the value that is attached to the item in question. So for example, the total number of exercise book in, let's say, a box. Let's say the total number of, let's say, mangoes in a basket. You get that? So that is the idea about what? A discrete word data. It has what? A number that represents the data that we are talking about. So that is a discrete data. So take note of that. Question 5. A parameter is a quantity calculated from the observation in a, we said a parameter, if you can remember when we were having the introductory part of statistics, we said for us to know a measurable characteristics or a value that represents the total population that we are studying, we use the term parameter. So parameter is a characteristic that helps us to estimate the population that we are studying. So the measurable characteristics of a population is called what? A parameter. Is that okay? So here is what? A parameter. That is, so is what? Population. Sorry, that's population I'm trying to talk about here. But then a sample, we call it what? Static. A sample is called what? Statistic. That is for a sample. Statistic. So a measurable characteristic of a sample is also called a statistic. So as you move along, you should be able to. So anytime you want to know a measurable characteristic of a population, is called a parameter, but a sample is called statistic. So please take note of that. Then question 6. Which of the following statement best describe the relationship between a parameter and a statistic? So we say a parameter is for estimation of population, measurable characteristics of population. Then a statistic is also for what? A sample. Is that okay? But then let's see. A parameter has a sampling distribution with a statistic as its mean. B, a parameter has a sampling distribution that can be used to determine what values of the statistic is likely to have in a repeated word sample. C, a parameter is used to estimate a statistic. Then D, a statistic is used to estimate what? A parameter. We said that for us to actually undertake, let's say we are undertaking a research on studying student performance with the use of technology. How is student performance being affected by the use of what? Technology. Okay, and we want to study will it be possible for us to study everybody to know their performance and in relation to the technology that they use? You see, when we want to undertake that activity, it becomes very difficult for us to get all the members who will actually be within for us to actually study the performance of a student and the use of what? Technology. So in that, because it will be very difficult for us to actually know all the members that will be within this research and study that we are undertaking, it's very difficult. So the best way that we go is to select some few from the total population that we want to study in terms of their performance, and that will help us to, because they will have certain characters that will be common to each and every member. So once we pick sample from, then we can study the sample and then use to make an inference that okay, if the performance of the student is increasing, then it's as a result of the use of technology and in a better way. If it is decreasing, then or it's reducing, then it's as a result of they using the technology maybe in a different way that actually limits or reduce their performance. Is that okay? Good. So if that is the goal, then we said that a parameter is a measurable characteristic of what? A population, a value that we use to estimate for a population. Then a statistic is also a measurable characteristic that we use to estimate what? A sample. After that is clear. So here, since it will become very difficult for us to have every member to be within the population for us to study for their performance and then the use of technology, then you are going to use a sample to make an inference from the population. And if that is so, then option D shows a statistic is used to estimate a parameter. So here the relation that will exist between a parameter and a statistic is that then it is certain that statistics will be used to estimate the population or make an inference. More like a sample can be used to estimate the population. Is that okay? So that is the whole debate. We don't use parameter to estimate because that is not for you to undertake a study and you are studying a particular group of people with respect to your research topic. How can you use the population to the whole bigger population to study a smaller? No, that wouldn't be so. So we use part of the population to study the bigger population, alright, or a bigger picture that you want to undertake. So here, statistics is actually used to estimate a parameter in that case. So let's take note of that. So let's move on to question 7. Data collected over a period of time can be graphed using A, Gantt chart, B, pie chart, C, time series graph, D, Pareto graph. So which of them do you think is going to be? Say the Gantt chart is a chart that we most of the time use for planning and projects, modeling for planning projects and do stuff. If you are not taking a very long-term project, right, and you want to know how to go about your things, you can use Gantt chart to do that. Pie chart is also another form of what? A pictorial chart that shows the relation between part and what? A whole, right? Then time series graph is also one way of what? Representing what? A set of data that has been what? Collected over a period of what? Time. And Pareto graph is also more like a bar chart. You have what? Bars and then lines in that case. So here the best option here is for a time series what? Graph, because it helps us to make pictorial presentation of data that has been collected over a certain period of what? Time. So the correct answer is what? Time series graph. So let's take note of that. Question 8. Which measure of central tendency can be used for both numerical and categorical what? Variables? A, we have mean, arithmetic mean, then B, we have median, C, we have mode, then D, we have standard deviation. You know, standard deviation is not part of central tendency, so that one is out. So now let's focus on the 3. The question is saying that can be used both numerical and what? Categorical what? Variables. Let's see. Numerical means what? Number. We are talking about the number or the number of the data. That's the number. So that one is very clear. When it comes to categorical, we are talking about what? A group that a member what actually is in. Let's put it in that way. For example, let's use blood type. Blood type. Blood type. You might see that we have people with what? O positive, we have people with what? B positive, and those types A, B, negative or positive, whatever it could be. And just for the purpose of understanding or explanation here, you can see that those with O positive will be in one category or will be in one class. Then B also will be in another category, and A, B also will be what? In another category. So that is their category. So let's say if we have those who are O positive, let's say they are 10, it is there. So that is their number. B, let's say it was 5. A, B, let's say it was 7. That is their number. Meaning that those who are in O positive cannot be in B positive. Isn't that true? Yes, because you are just in one type and you cannot change to another. So your blood type is what? O positive. Another person also what? B positive. So since a member from O positive cannot be a member in B positive, it becomes a categorical form, meaning that you will be within that group for the rest of your life in that case. So for example, as I'm trying to explain, so in here we can know that which of these central tendencies will help us to know if we are having a group and we are having what? It's a number. Arithmetic, we said arithmetic means help us to actually take into account the total number divided by the total summation of data divided by the number. Median, we try to locate the middle value of what? The data. Then we say mode is what? The most occurring. So if I have a group of what? Let's say I have a data, and then within that data we have certain variables that are occurring the most. That data has occurred the most. That's the mode. It has occurred the most, and once they occur the most, they will actually separate themselves from the rest of the data. Isn't true? Yeah, it's true. Because if let's say you have a group of, let's say, people with O positive who are many as compared to the rest of the type of blood I want to study, then we can say that people with O positive is actually what? They are many, so they will be in just what? One class alone. So once they are being that one group, then we can say that that is their group that they are in. Okay, so here the approach here is that since the most of the blood type that's occurring within the data is what? O positive, for example, then we can say that here a measure of something that will help us to estimate, or can use for both numerical and categorical variable with what mode, because it will help us to know the number and the group in which a particular word variable falls in that case, and it wouldn't be whether median or arithmetic mean. So please, let's take note of that. I've explained a lot, so if you are getting value out of this, comment. If you don't get things right, you can also comment in the comment section. I'll give you a response to that in that case, but I believe that you have gotten it right. So that is mode, so let's take note of that. Then we have question 9. A bacteria count in a certain culture increased from 1,000 to 4,000 in 3 days, right? What was the average percentage increase per day? And here too, this kind of questions will also been repeating itself in our previous 3-part series video that we made on MCQs on statistics. So please find time and go through them as well in that case. So here, if you have been going through for following our 3-part series that we have done so far, you can clearly see that this is what a geometric mean form of what estimating a mean, which we said that this form will be the value of the data at the end over the value of the data at start minus what 1, and all multiplying by what 100. If you remember, it is one of the questions in the previous video you have done. They are on the discussion session, you can check and build up. So that's a geometric mean. So you're going to consider this formula. So let's see, I made a presentation here. So here the average percentage increase per day in a question will be the bacteria at the end and the bacteria start minus what your 1, and all multiplying by what 100 in that case. Multiplying by 100 in that case. So here you can see that the bacteria at the end was what 400 in the question, this one, and our start was what 1,000. So that is why we have the 400 here, and we have what we have the 1,000, we have the 400 here, and we remember the growth period was what 3 days. So that's how come we also having what 3 days here as the end fruit type, which is the 3. Okay, so when you actually substituting these values and with the help of a calculator, you should be able to arrive at what 58.74 in that case, and that would be for option what D. Option D in that case. So option D will hold in this case. So option D is the choice that we are talking about, option D. So let's take note of that. So if you calculator, you can actually get the answer very fast and quick. Question 10. A variable that can assume any value between two given values is called A, random variable, B, continuous variable, C, discrete variable, D, attribute. Which of them is certainly going to be the answer? I know you know, right? So here is what a continuous variable. Example is like a temperature. Example is a temperature. You can take note. So that's a continuous what variable. Example, temperature. So let's take note of that. I hope you are getting things right. If you are getting value, please like this video, and if you are new, please consider to subscribe to this channel so that we can engage with you anytime I release any new video. You will be the best person to get it right away on your device. So let's continue to watch. Thank you for still watching this video up to now. I'm much appreciated. Thank you once again. So let's continue. Question 11. A data set is a collection of data. A data set is a collection of data values. A data set is a collection of data values with each value in a data set called, let me come again. A data set is a collection of data values with each value in a data set called, for example, I have, let's say I have 3, 4, 5, 6, 7. This is my data. It's called a data set. 3, 4, 5, 6, 7 is my data set. Let me put it in curly bracket form. It's my data set. So what is each value? Let's say 3, 4, 5, and 6. These are the the values within the data set. What is the name for a single value within a data set? That's what the question actually wanted us to know. And a single value within every data set is called what? A datum. So option A is the answer. It's called what? A datum. So a datum is a single value or variable within a data set. So that is a datum, and not attribute, and not variable, and not an event. So let's take note of that. Question 12. The process of using data collected from a small group to reach a conclusion about a large group is called A. Statistical inference, B. Scientific method, C. Sampling, D. Descriptive statistics. So which of them is going to be? We said that for us to actually know the research that we are actually undertaking, or the study that we are undertaking. So here it is called what? A statistical inference. So statistical inference is basically using small parts of what? Using small parts of what? A data, which is a sample, to make a conclusion about the larger what? Data, which is the population in this case. So let's take note of that. So it's what? A statistical inference. And not scientific method, neither sampling nor descriptive statistics. So let's take note of that. Question 13. The ratio scale of measurement to. So this one is also another question that we have been meeting them through our 3-part series we have done. So you can check as well. The ratio scale of measurement: A. Usually involves ranking. B. Cannot assume negative values. C. Has a meaningful zero. Then D. Is usually based on counting. So if I have 0 cedis and you have 100 cedis, who is worth with money? It's true that you are having 100 cedis. So here we can say that 0 is actually a true value, because if I have 0 cedis, I have nothing on my own. But if someone have 100 cedis, have what? Money on his own. Is that okay? So here the 0 is what? Meaningful, is important when it comes to what? Ratio scale. So the answer is what? C. In ratio scale of measurement, 0 is a meaningful what? Value or a variable. So let's take note. Question 14. Let's move on. A nominal level of measurement classify data into. We say a nominal level, we are talking about membership. We are talking about what? A category of group in which once you are in that group, you cannot be in another group. For example, taking a gender, we have male and female. So if you are male, you'll be in a male tell. If you are a female, you also be in a female group. And here, this gender becomes what? A nominal level of what? Measures a nominal data in that case. Because if you are a male, you are in a male group. If you are female, you are in a female group. So once a member in one group cannot be a member at the same time in another group, if I want to represent them in a form of what? A data set, for example, let's say I want to represent in the form of circles. So if I have, let's say, group A and group B. Okay, so group A is a male group and group B is what? A female group. Meaning that group A, if you are a male and you are in group A, you cannot be that of in a female group, isn't it? Sure. So meaning that if that is true, then we are saying that in the nominal level of measurement, data are mutually what? Exclusive. Data are mutually what? Exclusive. It will actually exclude you if you're not part of that group. It will exclude you from being part of that group. So data are mutually exclusive. And when we have data which are mutually exclusive, these are their representations is said to be. They are always separate apart, and then they won't be what? Overlapping. So meaning that if it were to be mutually inclusive, then it would have been a nominal what? Data. And in that, if a person in group A can also be in group B, and would have had a circles like this, where they will be overlapping, meaning that a member in group A can also be what? A member in group B. And since a nominal level of measurement of data, there is mutually exclusive what? Set of data, then there will be what we call overlapping of what members, or overlapping of what categories. So you have category A and category what B. So when it comes to nominal level of measurement, we are saying that it is non-overlapping what categories. It's also the same thing as, or it also mean same thing as mutually what exclusive. So the answer is what B in that case. So let's take note of that. 15. Which of the following is not a measure of central tendency? Is there a measure of central tendency? We are talking about the center for the data. Is that okay? Good. So here we have 5 categories or 5 elements of what measure central tendency. We have the mode, we have the mean, we have the mean, and the mean is breaking down into 3 parts. We have the arithmetic mean, we have the weighted mean, and we have what we call the geometric mean. So in here, if I didn't mention any item that doesn't fall within this option, then it's not part. So meaning that it is selling to what D, which is not part of what the measures of central tendency. Q3 is not part, so take note of that. In a right skew distribution, it's the same thing as in a positive skew distribution. If you don't hear of right skew distribution, you'll be heard of what in a positive skew distribution, meaning that you're going to have your distribution like this, where it's going to chop to the right hand side, okay, or move to the right direction. And in that, you have your mode always causing a division between the two. Causing a division between what the distribution and then your median somewhere here, and let's say your mean will be here. And if you are moving to the positive side, meaning that your mean will have a value that will be greater than what the median, right? And median also will be greater than what the mode, because they are moving to the positive side. So in here we can say that if in a right skew distribution, we can say that A, the median equals the arithmetic mean. That is not true. B, the median is less than the arithmetic mean. That is very true. C, the median is greater than that. That is not true. They're none of the above. So it is certain that B, the median is less than the arithmetic mean, will be the best option. That's option what? B. So let's take note of that. So in a right skew distribution or in a positive skew distribution, that is how the mode, median, and the mean relate in that case. So let's take note of that. And it's also certainly true for the opposite, that's in a negative skew distribution or in a left skew distribution. The approach is also true for that. So let's take note of that. 17. Another name for ogive in statistics is called A, frequency polygon, B, histogram, C, cumulative frequency, D, bar chart. I want you to answer or give me the answer for this question. Put in the comment section. I'm giving some minutes. 5 seconds. 1, 2, 3, 4, 5. So what is the answer? The answer is what? A cumulative what? Frequency polygon. Because we said a cumulative frequency polygon is also called what? An ogive. It is actually a cumulative frequencies that is being plotted against what? The midpoint or class boundary. In that case, we can actually use for that. So that is question 17, and the answer is a cumulative frequency polygon. So let's take note of that. 18. Which graph should be used to show a relationship between parts and whole? And what is the name of that graph? It is what? A pie chart. So here, that is that. I hope you are getting this, right? So if you are getting value out of this video, comment and like this video. Thank you. So let's move on. Question 19. The number of adverts on 1-hour television show is an example of what type of data? We are talking about number. Even if you don't know anything at all, please. Number. We said a discrete data have what? A value that attached to the data that we are talking about. So even if you don't know a discrete data, then Once the number appears, then you can even make that inference and conclude that this data is a discrete data. So discrete data is true for this, and not continuous data, neither quantitative. It's a quantitative data. I mean, it can be so a number, but then here we want a specific quantity, because quantitative we have continuous and discrete, but we want a specific type, not a general one. So that's why it makes it what a discrete data. Let's take note of that. Question 20. The mean annual salary for all employees in a company is 36,000. The mean annual salary paid to male and female employees of a company is $34,000 and $40,000 respectively. Determine the percentage of males and female employed by the company. How do you determine that? So first thing that you need to do is to let a representation of what the overall mean for all the employees, and then the mean for both gender, 34,000 for males and 40,000 for what females. You present and give what it a representation to stand in that case. So let's see how I made a representation here. So that's how actually you go by that. So I said first, let the total mean annual salary, that's overall, be what X. This one, sorry, let me indicate here for you. This one, right, be what 36,000. That was there. Then likewise, this one too, it was 34,000. Then so I use the symbol mean, which is this, and M of F was for the overall, then the small m was for the male, and then F was for the female in that case. So after representing them, then you know that to find mean is what the summation of what the values in data divided by their number. But here we don't know the number, that's what we are here to find. So I made a representation that let the total number of males and females be what n1 and what n2 in that case. Okay, so since I know their mean, and then I don't also know the number, I also know the sum, I made a representation to find the mean of, let's say, the male. It is what summation of what the number of males divided by what their number, which I made it as what n1. Okay, so that's what I did here. That's what I did here. This one. Then all that I do is substitute the mean value, which was for 34,000 for the male. Okay, so when I substitute, all that I did here is to make what this value the subject. So once I made the subject, it becomes what n1 multiplied by what 34,000 in that case, and that's how can we have this value summation x. This one we had what 34,000 multiplied by what n1. Okay, and the same we're going to do for the female too. So we're going to have what 40,000 and 2. So once you're able to get the two values, then we also know that in the question they gave us the total mean to what 36,000. This one 36,000. Okay, so in that, for you to find the total mean, you are going to add the total salary for the male and the female, okay, and divide by their number. And when you do that, you're going to get this. You're going to get this, the one I've indicated with red. Okay, you're going to get that equation. Then after that, you make the number 1 and number 2 what the subject. So that is what I did. Then I was able to arrive at this ratio. So in that, you can see that in terms of their ratio, the male will have what 2, and in terms of their and the female will have what 1. So meaning that their total number in this case is going to be what 3. 2 plus what 1 going to be what 3, and that's what I did here. Then I made 2 divided by 3 and multiplied by 100 for the males, and I had 66.7 and that of the females, which also should be what, 1 out of 3, then also add what, 33.3% in that. So that is how actually I made it. So it's not anything difficult, so you can go through and understood it. So that is the whole deal that you're going to. So first of all, let a representation of the two mean, that is the male and the female. You find the total salary for the males, find the total salaries for the females. After getting the total salary, you add the two total salaries together and divide by the total number of the employee, which consists of the male and the female. And in that, you're going to get the mean for the 36 that the question gave to us. So here, our interest was to find what the total number of employees, and we arrive at what, a ratio where we have 2:1. The 2 was standing for the male, and then the 1 was standing for the female. So when you convert to the percentage form, it's 66.7 and then 33.3% in that case. So please find time to go through. It's very simple for you to get it and get it right. All right. So here, the answer was what? A in that case. So let's take note of that. Question 21. What are the boundaries of 25.6 ounces? Ounces more like a unit of measurement. Most of them used for masses, weight, and those stuff. So if you are ahead of the first time, then that is the meaning of ounces in that case. What are the boundaries of 25.6 ounces? So here, the idea here is that you must look out for what, two values, in which one is constant and another one is what, a variable, and in which when the constant value is being added or subtracted from the variable, you are going to get what, 25.6. This is what I'm trying to, let's say I have y plus or minus x. Okay, let me use this so that y plus or minus x, and is equal to what, 20 is equal to 25.6. Okay, so these are the two values I'm talking about. So here, let the x be a constant value. Let the x be a constant value in that case. Let the x be the constant value in that case. So meaning that all that we are trying to denote here is that if I should add or subtract the x from the variable y, you should be able to get me what, 25.6. So how do you then come out with what, the value of x, which is constant, that when you added or subtracted from y, you should get what, 25.6. And here, if you were not limited, here I'm limited, I'm given an option, so that I need to follow. So I'm going to do what we call a test of it to find out the value. But here, in the case where you are not given any option, you are not limited to any options, you can actually use any two variables, that when you add or subtract with a constant and your variable, you should be able to get what, 25.46. But here, because I was limited, I was given an option, that is how I can't actually use any variable at all. Okay, if I wasn't limited, I can say that if, let's say, I use 27 okay, as my variable, or let's say, let me start with the constant, because that would be, let's say I'll say the constant, let's say constant 1, it should be 1. So if it is 1, then it should certainly give me 25.6. Okay, when I add it to, let's say, the y, that is the variable, it should give me what, 25. So if I want to do that, then I can say that if I want to deal with the addition, y plus 1 is equal to 25.6. So if I want to make y the subject, I'll subtract 1 from the 25.6, and that will give me what, 24.6, isn't it? Yes. And the same is also very true for the negative. If I want to deal with the negative side, which is y minus -1, that will give me what, 25.6. So if I make y the subject, becomes what, 26.6, and that would have been my what class boundary for 25.6 in this case. But here, because I was limited with an options, I can't go by that approach. And then if you are not limited, each and every person will get a different class boundary. But then when you manipulate with the constant value, which is here in this case I've been at S, when you add or subtract from the variable, which is the Y, you all arrive at 25.6. okay, so that is the goal. But here, because I was limited, which value would you think if I should add or subtract from Y, it will get me what 25.6, and reference to the options here, the A and then B and the C and the D, which of them? So let's see how I made a presentation here. So this was a presentation. So here, as I said, the idea is that you are looking out for two values in which one is constant, in which one is what constant, and another is what another one is what another one is a variable value. And as such, when the constant value is added or subtracted, it will fetch you the number in question. And here the number in question was what 25.6. In this case 25.6 I've underlined. So I represent the constant value to be what X. Okay, and then I said that the value that I should be added or subtracted should be 0.05. And when I go for the addition, I had 25.55. That was the addition. Then when I did the subtraction, that's because it was plus or minus. So when I did the subtraction, Y minus 0.05, I had what 25.65, and that was my class boundary that I had for 25.6. And one clue here is that after getting the class boundary, and if you want to determine whether your answer is right, there's a way of determining whether the class boundary you had is right. This is what you do. You first of all take the difference between the two class boundary limits here, which is a 25.55, the 25.55, and then 25.65. You take the difference. When you take the difference, you will get something like 0.1, I think so, 0.1. And then once you get a 0.1, you divide by 2. If you divide 0.1 divide by 2 and get 0.55, then it means that what your class boundary is what's right. Even if you are not limited, I mean with options, and you want to know whether your class boundary are derived for that value or that value in question or that figure in question is right. After that, you find a difference between the class boundary, more like your class root, and divide by 2. You're able to get your constant value you use to add or subtract from the two values. That's the variable here, and you get it right. Then it means that your class boundary will be what right. Please take note. I've said a lot of things, so make sure you take them one by one and go through. So that is the whole deal about how we go by this approach. So class boundary. So the class boundary for 25.6 was 25.55 and to 25.65 in that case. So let's take note of that. So you can certainly see that the answer was what? B. That was 25.55 to 25.65.6. So let's take note of that. So let's move on to question 22. For a frequency distribution in statistics for 100 students, the arithmetic average was found to be what? 50. Later, it was discovered that max 48, this max 48 was measured as what? 84. We are asked to find the correct what? Mean. Realize that the number of students was what? 100, right? And our mean, which was X bar, was what? 50. That is where there was an error, because the 48 marks should have been, the 84 marks that we included in the total summation of the total marks should have been what? 48 and not what? 84. So we need to find the total marks in that. So to find the total marks in that case, it's going to be your summation X multiplied by the total number of students. Okay, and that's going to be 50 multiplied by 100. You're going to get what? 5,000. So after getting the 5,000, all that you need to do is that's the total what? Max. You subtract the max that we misread. That was what? 84 from the total max, which is what? The 5,000. And you correctly add back the actual max, that should be 48. You add back after subtracting the wrong value that you added to the max. So that is what I'm trying. So this is what I'm trying to tell you. 5,000, sorry, minus 84 plus what? 48, and that will be the total max for the 100 students in that case. So whatever you're going to get, you divide by what? 100. That's the total number of students, and you get the proper mean for the 100 students and their respective marks in that. So let's see how I made a presentation here. So as I said, I had a total number of students to be 100, and the arithmetic mean was what? 50. Yeah, 50, and then 100. So I made that since max 48 was considered as what? 84. Then to find the mean, we say summation x over what? N. So I want the summation x is the total max that I want to determine. So I made summation x the subject, and I able to arrive at summation. So the mean x by multiplied by n, and then that's why I able to manipulate, substitute the figures in there. The total number was 100, and then the mean was what? 50. So my total max for the student, 100 students, would be what? 5,000. Okay, and then that was before correction because there was an error in the math. So to correct it, you subtract the misread value, which was 84, from the total mass of 500, and you add back the original value, original mass, that was 48, to the total what? Max, and that will fetch you what? 4,964. That will be after the correction of their total mass after the correction. And for you to find the correct mean after the correction, it is their total mass divided by what? The number of students, which was what? 100, and that will fetch you what? 49.64 in that. So that is their mean, which is 49.64 after the correction. So let's take note. So here the answer was what? C, 49.64. So that is that. Question 23. Out of 100 engines tested at the workshop, 20 were 4%, 40 were 5%, 30 were 6%, and the remainder were 7% what? Effective. Find the mean of the tested engines. Find the mean of the tested what? Engines. So here too is also another approach. Here you have been carrying a weight. You have a weight that has been assigned. In terms of their effectiveness, 20 were 4% effective. Mean that these machines were not all that great. In terms of their efficiency, should I say their efficiency? Yeah. Because if you test for it, 20 were 4%, then it means that there's something wrong with the machine. So just by the way, so let's see how I made a presentation. But remember, there is an application form for a weighted mean, so take note. So this question, as I said, is an application of a weighted mean. So to find a weighted mean, you multiply the weight attached to the data set, then divide by the total weight in that case. So you realize that the weight was for 4%, 5%, and 6%, and we're having 7%. But remember, in the question they said that in the remainder of 7% effective. So for you to get the remaining machines for 7% effective, you add 20, 40, and 30. When you add, you don't get 90, and subtract from the 100. The remaining machine will be 10, and that will be for 7% effective weight. So that's how come we had the 10 here. This 10. So take note. That's how come we had the 10 in that case there. So when you multiply the percentage by their respective machines and divide by total, which was what? Percentage, so you're going to be 100%. You should be able to arrive at what? 5.3%, and that was option what? That is option B, which is what? 5.3%. So that is the whole. Just multiply the weights and divide by multiply the weight by the data and divide by the weights, and that is all in that case. So I hope you are getting value out of this. So if you are getting value out of this and you haven't liked, please like this video, okay? And you haven't subscribed, be sure to subscribe so that we can get more engaged on this video and on this channel as well, to assist more people to transform their academic life. So let's continue. Question 24. If you remember, question 24 is a repetition of one of the questions that we actually just gone through. I think that was question 9 or so. Question 9, just a repetition in that case. So a certain bacteria count, remember that we said is the end fruit, and we said it's a geometric mean value at the end, value at start, right? If you remember, -1 or multiplied by 100. If you remember, that was the deal. And I've made a reference, that was question 9, so the answer still remains the same, which is what, 58.7 in that case. So let's take note. Question 25. A multimodal frequency distribution has more than, please take note of distribution here in this case. The modes has been distributed in a frequency form, in a distribution form, which can be in the form of a normal distribution or any form actually. So it's saying that a multimodal frequency distribution has more than 2 dash. A multimodal frequency is a frequency which has a mode value which is what, more than what, 2. If we were to be bimodal, mean that bimodal means the mode is what, 2 values. 2 values. But if it's multimodal, it's more than what, 2 values or 2 modes. Is that okay? Good. So in a multimodal frequency, if I had to represent a multimodal frequency in a form of a graph, for example, let's say I have my first mode. Let's say my second mode will be a peak light, and my third mode, if you remember, in a normal distribution form, this is my first peak, this is my second peak, and this is my third peak for the mode. Let's say 3, because I'm into multimodal, which is more than 2 mode, right? Okay, so if that is true, here you can see that this curve is more like what, a maximum curve. Is that okay? Yeah, so you can see this is a maximum curve. So in a multimodal frequency, we have what, more than 2 what, maximum what, modes. So when you hear of multimodal frequency, you are talking about what, when I represent them in the form of what, because if you remember, when we were doing the skewness, we said always the mode is always the first, that will cause a division between what, the distribution in that case. So here will be the mode, if you remember, in the skewness form, and the rest will become the mean and the mode will be coming. So here we are talking about multimode, we are talking about mode, and the mean is not part, neither the median is part, okay? So you'll be dealing with this, the maximum and then parameter. So in a multimodal frequency, the mode, there are 2 distribution frequency has more than what, 2 what, maximums. So it has 2 maximums and not what, parameter. Most of the time you might see that maximum or what, maxima. Then you may see this or maximum. Any of them is the same thing in that case. So just take it like that and then move on in that case. So in a multimodal frequency distribution, we have more than 2 maximums, more than what, 2 maximums. So please take note of that in terms of their normal, in terms of when they are being distributed in a normal distribution form, in a normal curve form. You always be in a maximum in that case. So take note of that. So as I said, it can be a maximum or in a maxima. Any of them, they are the same. Let's take note. So this was just a summary of what I was actually proving here. Okay, and so let's take note of that. Let's take note. So this is the summary. So I said it's a normal distribution. So Let's take note. Then question 26, we are given this sample data. Remember, I said it's a sample data, so take note. Sample data, where is 3, -2, -4, 1, 0, -1 and 2. And the question is asking us which of the following is true, which of this option is true. So you are going to test and find out. So you want to find what? The mean. To find the mean, we add all these values, 3, -2, -1, 1, 0, -1 and what? 2. We add all of them together and divide by how many numbers, how many frequencies in this case? 1, 2, 3, 4, 5, 6, 7. 7. The frequencies was 7. So you add all, then divide by 7. If you get this, then fine. If you don't get it, no problem, then you continue. So that's what you're going to do. You take the option, then you work it out using the sample data. You work the sample variance with the same sample data, and you take the same sample data and you work out for sample standard deviation, and you also do the same for the median in that case. So let's take, so the sample, let me draw you attention on this thing. With the sample variance, okay, that is what is what we present as what? The x square. That is sample variance. But the sample standard deviation, you either see x or what? Something like this. X with what? A small s attached to it. And these things are always on calculator. Casio 991EX. You see there. If you want to use, the calculator to solve for this, when you see this, that is how you find a sample standard deviation. Okay. Now when you see the s square, though on the calculator you cannot find a sample variance, but then you can find a sample standard deviation and you squared it. Once you square, you're going to get your variance. Because we said to find a variance, a square of 4 standard deviation. Likewise, the opposite is also true. If you want to find what? The standard deviation, the square root of what? The variance. So no problem. So let's see how I made a representation here in this case. So I find the mean and I had what? Negative 0.142857. And let's see whether it was the same thing here. It was negative 4.1. So we mean that the mean is not part, it's off. Let's see that of the median. Median means the median what value. So you arrange them in ascending order and realize that because the data values or the samples was 7, the first 3 values from in ascending order from -4, -2 and -1, you end it, then you come back and count the last 3 digits, which is what? 2, 3, 2 and what? 1. So meaning that the middle value is going to be 0. So let's see. The median is -1, but then we had what? 0. So meaning that median is also what? Out. It's not pass, so it's also out. So let's go for a sample variance. So when we estimate the sample variance, so the sample it is a formula for sample variance. Summation x minus x by all squared all over n minus 1. I hope you have seen this formula throughout. So this one I use a manual way to solve for it, okay, but you can use calculator. But as I said, with the calculator form, I have a video. I think that's part 2 of our discussion on MCQs. Question 22, actually specific question 22, I have give a detailed explanation about how to turn a frequency on and substitute the values of x and then their frequencies in that, and know how to solve this kind of variance and then the standard deviation questions in there. So please try to look at that. I've given the links in the description section of this video. They are all here. After here, try to visit that video and attend to the explanation that I gave there when it comes to using calculator to solve for these kind of questions, so that you won't be wasting time when you're in examination conditions. So please take note of that. So when I estimated that with the manual form, that's a workings form, I had what? 5.81, and in that, let's see, sample variance was what? 5.18 and not what? 81. So meaning that sample variance also what out. So what about the sample standard deviation? So we said sample standard deviation is going to the square root of the summation x minus s by all squared, or divided by n minus 1. And we said the sample variance was 5.81. So all I will do just to take the square root of what? The 5.81, or in that case, before the 5.8, so is the 5.8081, then I'm getting what? 2.41. And the sample standard deviation will be what? Correct. And out of these options, it is actually the sample standard deviation that represents the sample data in this case. So let's take note of that. So see how I actually solve it. Okay, because we have done this part of videos in our other series video that we covered. They are on their links. The links are on the description section of the video, so you can check and then watch more. I've given a detailed explanation there. This is just a way of actually going through with what we have done so far, so that you appreciate it much more better. So let's continue. Question 27. A final examination in a course is weighed 3 times as much of quiz. Find the mean grade of a student if the student had a final exam grade score of 85 and a quiz grade of 70 and not 90. They are saying that for a final exam, the weight is what? 3. And then the quiz, the weight is what? 1. So every quiz that you do, you have a weight of 1. And the final examination, you have what? A weight of what? 3. Or it weighs what? 3. Okay. So if I have what? 85 as my final examination score and a quiz of 70 and then 90, meaning that here is also a weighted what? Mean average. So they are asking us to find what? The mean grade of a student. So here I'm going to use a weighted what? Mean to do that. So let's see how I made a representation here. So as I just illustrate, the final exams will have a weight of 3, and then the quiz also have a weight of what? 1. So to find the mean, it's actually the multiplication of the 3 by the 85, and then remember the quiz also 1, so 1 multiplied by 70, 1 multiplied by 90. So add all of them and divide by their weight, which was what? 3 plus 1 plus 1. So here the weight was what? 5. So when you divide, so after that, when you manipulate the whole whatever you have as a numerator here, you're going to get 4, 1, 5, and then divide by 5. You should be able to get what? A as what? Option A, and which was 83.00 as the mean grade in that case. So here the answer was what? A. So let's take note of that. Then question 28. A quality construction company pays its hourly employees 6,500, 7,500, 8,500 per hour. There are 26 hourly employees. 14 are paid what? 6,500. 10 are paid 7,500, and 2 are paid what? 8,500. So what is the mean hourly rate paid to the 26 employees? So how are you going to do that? So here we have actually allocate or categorize the employees in terms of their pay. 14 are paid 6,500. 10 are paid what? 7,500. 2 are paid 8,500. Meaning that it's more like we have assigned weight in terms of the wages that they are receiving or the salary that they are receiving. We have those with a higher, and we have those with a lower, and we have those with a medium or salary, based on maybe probably the type of employee that you are. Okay, so you see the 2 people are paid what? 8,500. They are paid at a higher rate as compared to the rest. So let's see how I made a representation. So this one's also to a weighted what? Application. Weighted mean application. So let's take note. As I've indicated here, these are the differential hourly rates. The 6,500, 7,500, and 8,500. Our total employees were what? 26. So I made this table that you have allocation of employees and their hourly rate. 14 are paid what? 6,500. 10 are paid what? 7,500. And 2 are paid what? 8,000. So here the same weighted mean. Multiply the 14 by what? 6,500, because that's what they are paid, so that we know the total payment or total money we paid for. Those are the hourly rates of 6,500. Then 10 for 10,700. Then 2 for what? 8,500. After that, divide by the total of employees, which was 14 plus 10 plus 2, which in other words 26. Then you manipulate and you should be able to get your answer. So 7,038.46, and that will give you option what? D. This option D. That case, so that is how we solve this kind of. It's very simple and then easy to go. So let's take note of that. So that is summary. Then you have question. You have to use the data below to answer question 29-30. So the table below shows a frequency distribution for a number of minutes per week spent watching TV by 400 junior high school students. Okay, so you have their viewing time, the minutes, and the number of students in that case. So these are the table, and then it continues in this way. The total frequency is 400, so take note. So we are asked to find what? Which of the following values represent the mean? We are asked to find the mean. Here too, as I said, the part 2 of my MCQ solving on statistics. They are on the description section of this video on statistics. Question 22, please visit there and check. I've given an explanation about how we use calculator to solve. Because when you are given this kind of data, examination condition, if you're not very fast and you're going to use by the manual way, you won't finish. You'll be wasting time. So you need to know how to use calculator to solve for this kind of questions so that you can save time. So as I said, visit that video. The links are in the description section. Question 22, part 2 of my statistics MCQ solving. Question 22, please visit that question and then see the explanation that I give there, and then you can use it solve for this in that. But then all the same, I'm also giving the explanation also, or the manual form of solving the mean. We said the mean in a group data x bar should be called summation f of x over summation 1 to f. So if you have this formula, then you should be able to estimate. But one thing that you also need to know here is that here you have been given in the class what interval. So for you to get the value of x, you must find what we call your midpoint. And midpoint is found by adding the lower class limit plus the upper class limit together. When you add the 2 and divide by 2, you get your midpoint. Or lower class boundary and upper class boundary, you add the 2 and divide by 2, you get your midpoint. Anyway, you still get your midpoint. So let's see how I made a representation here. So this is a large table that I did. I have the viewing time, you have the number of students, you have the midpoint, class boundary, cumulative, and then f of x. So here, for me to get my midpoint of 3.495, so as a result of the addition of 300 plus what? 399. Okay, and I divided by what? 2. That fetch me 3.349.5. The same thing is also true. I added 400 plus 499. I added 2 and I divided by 2 and I had what? 449.5. So that's what I did all through to get these values down here. So let's take note. So after getting this value, then you multiply so you're going to be the value of x. Multiply these values by the frequencies, which is this. Multiply by these values, which is the frequencies. So once you're going to multiply them according to their row form. So here 14 multiplied by what? 349.5, and that's going to give you 4893. Likewise, the same 46 multiplied by 449.5 going to give you 20,677. So that's how I did also able to get the values. And when I summed them up, I had here to be 286,000. I had here frequency to what? 400. So just cause the division between the two. Z mean is for summation f of s over summation f. So when I divide up, I had what? 715, and that was option what? A. Option A. This option A. Okay, so that's how we find what? The mean in that case. So let's continue. And the next question is we are asked to find what? The mode. Remember, in the same video that I made, part 2, we solved some mode question. We said to find the mode in a group data, to estimate the mode of a group data, it is the lower limit of the mode into bracket plus bracket first triangle 1, or divided by triangle 1 plus triangle 2, and then multiply by your class size. If you can remember, where we said is the lower class boundary of the modal class. The triangle 1 is the cumulative frequencies before the modal class, and triangle 2 we said is the cumulative frequencies after the modal class, and we said the C is the class width of the modal class. That's what we said. So this is the formula we're going to use to estimate the mode, and this is how come I arrived. So you see, let's look at this before we even come to this. Let's go back a bit. So here the frequencies, we have 14, 76, 8, 58, 76, and we have 68, 62, 48, 60, 22, and then 22 and then 6. Okay, good. So 22 and 6, good. So which of them has a higher frequency? It's going to be 76, and the class is 600 to 699. So let's go back to our question again. So meaning that our mode is what? 76. Mode is 76. That is the highest frequency. So for you to know the lower limit of the modal class, it's actually how we find the class boundary. Okay, if I said you locate the upper class limit of any class compared with the succeeding lower class limit. Okay, you take the difference between the two and then you divide by 2. So that's what I did here. Subtracted 399 from 400, I had 1. I divided by 2, and I had what? 0.5. So I added the 0.5 to the 399, I had what? 399.5. Then I subtracted 0.5 from 300, I had what? 299.5. So that's what I did for even the modal class, which was what? 600 to 699. So this was the class boundary for the modal class, 599.5 to 699.5. Okay, so here what will be the lower class limit? Is going to be 5.99, and that is here. Okay, and then we said the triangle 1 is the cumulative frequencies before the modal class, which is what? The 600 to 699. So we're going to add up these values. These values. So as I was saying, you add up these values. Let me indicate it. These values, the 14, 46, and the 58. That will be the cumulative frequency before the modal class, which is what? The 600 to 699. And then that's why I had 118. And then the triangle 2 is also the 68, 62, 48, 22, and then 6, which was the cumulative frequencies after the modal class. And that's why I had 2086. Okay, and then multiply by my C. My C was 100. How did I go by that? I take the difference between the class width of the modal class, which is what? 699.5 minus 599.5, and I had what, 100. When I manipulate, I had what, total of 635.92, and that was the answer for that in that case. So that was only for what, B in that case. So that was the answer in that case. So actually, that is our last set of questions. Thank you for watching this video.